Hi, my dear brilliant diamonds. In this introduction video, we are going to discuss bullet points or key concepts of this chapter triangles. What are they? Basic proportionality theorem, converse of basic proportionality theorem, similarity criterions. You have AAA, AA, SSS, SAS, RHS. These are the similarity criterions we are going to discuss in this introduction video. Before proceeding further, you have to recall which you have learnt in 9th class. What are they? Rules of congruent triangles SSS, SAS, ASA, AAS and RHS. So let us now discuss our first bullet point or key concept. What is that? Basic proportionality theorem. As per this theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then what happens? The other two sides are divided in the same ratio. Now, you want to understand this statement? Don't worry. See here clearly on the screen. You have triangle ABC. For this, you have three sides AB, BC, CA. Now, let us take this side BC. To this side, let us draw a parallel line, and that is what this statement is saying. What is that? If a line is drawn, means DE is drawn, how? Parallel to whom? One side of a triangle. So which side we have drawn? BC side. If this is the case, means if we draw DE is parallel to BC, then what happens? What it is saying? This basic proportionality theorem says that then this line divides the remaining two sides. What are the remaining two sides? AB and AC. To these two sides, this DE points divide in the same ratio. It means AD by DB is equal to AE by EC when conditions apply. When if DE is parallel to BC, then only. So this same statement mathematically we can write if DE is parallel to BC, then AD by DB is equal to AE by EC, AE by EC. This is what basic proportionality theorem states. Just now we discussed about basic proportionality theorem. What it means? If DE is parallel to BC, then AD by DB is equal to AE by EC. Now you should think reverse. Means whether if AD by DB, means if this condition is true, AD by DB is equals to AE by AC. If this condition is true, then whether it happens DE is parallel to BC or not, then answer is yes, and that is what we call converse of basic proportionality theorem. See here what converse of basic proportionality theorem says. If a line divides any two sides of a triangle in the same ratio, it means if this line is dividing any two sides, AD and AC are the two sides now for our case, this DE line is dividing these two sides in the same ratio. If that is the case, then what happens? This DE will be parallel to BC, means to the third side. So that is what the converse of basic proportionality theorem says. Let us now discuss when, how, and on what basis we can say any two triangles are similar. So those are the things we will call similarity criterions. We have 5 different types of similarity criterions related to triangles. And let us discuss the first one. AAA is nothing but angle, angle, angle similarity criterion. And see here carefully on the screen, we have two triangles. What are they? Triangle ABC and triangle PQR. Now, if you look at these two triangles, angle A and angle P, these two are equal. Angle B, angle Q are equal. Angle C and angle R are equal. These angles are called corresponding angles. If corresponding angles of two triangles are equal, then as per AAA similarity criterion, we can say those two triangles are similar. Now let us discuss AA similarity criterion. AA is nothing but angle angle similarity criterion. Again we have same triangles and observe carefully corresponding angles. Angle B, angle Q. These two are corresponding angles in these two triangles. Angle C, angle R. These two are corresponding angles. So these two are equal and these two are equal. If this is the case, means if two angles of a one triangle are equal to two angles of another triangle, then as per AA similarity criterion, we can say those two triangles are similar. Next, let us discuss SSS, side similarity criterion. So again we have taken same triangles. So for AB side, PQ is corresponding side. For BC, QR is corresponding side. For CA, RP is corresponding side. So if corresponding sides of one triangle are in the same ratio of corresponding sides of another triangle, then we can say these two triangles are similar based on side similarity criterion. Next, let us discuss SAS, side angle side similarity criterions. See here on the screen, AB and PQ are corresponding sides and they are in the same ratio, and BQ, angle B and angle Q are corresponding angles, then BC and Q are corresponding sides. So SAS, SAS, as per SAS similarity criterion, if corresponding sides are in the same ratio and corresponding angles between these two sides are equal, then we can say these two triangles are similar. Now let us discuss the last similarity criterion, RHS is nothing but right angle, hypotenuse and side. If you have two right angular triangles and as per this RHS similarity criterion, they will be similar if ratio of hypotenuses is equal to ratio of any one corresponding sides. It means if AC by PR is equal to BC by QR, BC by QR, or else AC by PR is equal to AB by PQ. So if this condition, any one of these condition is true, then we can say these two triangles are similar. Till now we discussed about similarity criterions. Before that we discussed basic proportionality theorem and converse of basic proportionality theorem. Now let us discuss about chapter. If you talk about exercise 6.1, first exercise, introduction, means there they will be asking very simple questions, which figures are similar, which are not similar. Second exercise is completely related to basic proportionality theorem and its converse. Third exercise is related to similarity criterions. So this is what all about introduction of this particular chapter. Hope you will utilize in a better manner this introduction. Thanks for watching and learning. Have a nice day.